All right, so welcome to another deep dive. And today we're talking about uh, measurements.
Measurements,
Yeah,
yeah.
those numbers that we use them for everything.
Everything.
Like from baking cakes to, you know,
To building rockets, yeah.
building rockets, exactly.
Yeah.
But we're going like a little bit deeper today, right?
We're going beyond just reading a ruler.
Okay.
We're going to explore, you know how those numbers can sometimes be a little fuzzy?
Fuzzy.
Yeah.
Okay.
And why that matters. And trust me, this isn't just for scientists.
Right.
Whether you're trying to follow a recipe or you want to figure out if that online deal is really a bargain, understanding how measurements work can save you a lot of trouble.
I mean, you're right. We just take measurements for granted, don't we?
You do, yeah.
Yeah,
But they underpin so much of our lives.
they do. Yeah.
And understanding their accuracy can be the difference between success and, well, let's just say a less than perfect cake.
Okay, so where do we even start with this?
Well, it's a good place to begin, but let's zoom even further to something called significant figures.
Significant figures.
Yeah.
Now, imagine you're following a recipe that calls for 2 cups of flour.
Okay, 2 cups of flour.
Now, what if your measuring cup only has markings for every half cup?
Oh, half cup, okay.
You're essentially guessing then between 1.5 and 2.5 cups.
Oh, okay.
But with a cup that has markings for every quarter cup,
Right?
you can be more precise.
Right.
You can land somewhere between 1.75 and 2.25.
Right.
And the more precise your tool is, the more digits you can confidently use in your measurement.
So it's like, I'm saying it's not just 2 cups. I'm really saying it's 2 cups to the best of my ability.
Exactly.
Mhm.
Those extra digits in a measurement, they actually tell us a lot about how carefully it was made.
Oh, okay.
And that matters because the more digits we have, the less wiggle room there is in our measurement.
So that's significant figures. They tell us how much we can trust a single measurement.
Right. But what happens when you start doing math with these measurements?
Ah, that's where things get really interesting.
Oh, okay.
Let's say you're adding 2 lengths together.
Yeah, adding 2 lengths.
You might be tempted to just add the numbers, call it a day.
Right, just punch it in.
But you need to consider the significant figures of each measurement.
Okay.
So if one measurement is super precise and the other is a bit rough,
Right,
our final answer can't be more precise than the roughest measurement.
right.
It's,
Gotcha.
it's about the weakest link.
So if one's really precise and the other one's not, the final answer can only be as good as the worst one.
Precisely. Let's say you're adding 703 to 7 and then to 0.66.
Okay.
If you punch it into a calculator, you get 710.66.
Yeah.
But because that 703 has no decimal places, we round the entire sum to 711.
Oh, interesting. So it's like the least precise measurement is setting the limit
Yes.
for how precise we could be with the result.
Yeah.
So what about multiplication and division?
Same principle applies.
Yeah.
Let's say you're multiplying 2.21 by 0.3.
Okay.
Your calculator will spit out 0.663.
Yeah.
But since 0.3 only has one significant figure,
Right.
we round the answer to 0.7. It's all about letting the weakest link determine the strength of the chain.
I see. So it all makes sense.
Yeah.
You know, if you're building a table and one of your measurements is off by a ½ an inch, it doesn't matter how precise the other measurements are.
Right.
Your table's going to be wonky.
You're going to have a wobbly table.
Yeah, this is giving me flashbacks to some DIY projects gone wrong.
I think we've all been there.
Yeah.
But the good news is that understanding these principles can help us avoid those DIY disasters in the future.
Right.
And it's not just about building furniture. It applies to all sorts of real-world scenarios.
Okay, now I'm really starting to see how this stuff matters beyond the science lab. Give me an example.
Well, imagine you're planning a road trip and using a map to calculate the distances.
Okay, road trip map. Okay.
If the map uses slightly inaccurate distances for each leg of the journey, the overall estimate could be way off.
Yeah, that's a great point. Suddenly, error analysis feels a lot less abstract
Right.
and a lot more relevant to my next vacation. And it makes you wonder how many things we rely on, like online reviews or even medical test results, are based on potentially flawed measurements.
It really highlights the importance of not taking numbers at face value.
Yeah.
Understanding how those numbers were obtained and what their limitations are is crucial for making informed decisions.
This is blowing my mind. Okay,
No,
so we've talked about significant figures and how they play into calculations. What's next on our deep dive into measurements.
Let's take a look at the tools we use to get those precise measurements in the first place.
Okay.
Specifically, I'm talking about vernier calipers and screw gauges.
Ooh, those sound like serious pieces of equipment. Are we talking about stuff that's used in like high-tech labs?
They might sound intimidating, but they're actually quite straightforward once you understand the principles behind them.
Okay.
A vernier caliper, for example, is like a souped-up ruler. It uses a sliding scale to give you a much more precise reading than a standard ruler could.
I vaguely remember those from school, but honestly, I was always a bit intimidated by all those little lines and markings.
Right.
Can you walk us through how to actually use one of these things? I'm sure our listeners would appreciate it too.
Absolutely. Let's say we're measuring the diameter of a cylinder.
Diameter of a cylinder, okay.
We'd place it between the jaws of the caliper and look at where the scales line up. Imagine that the seventh line on the smaller sliding scale lines up perfectly with a line on the main scale. And let's say the 0 on that sliding scale sits just to the right of the 3.2 centimeter mark on the main scale.
Okay, I'm trying to picture it. So how do those lines translate into an actual measurement?
Well, the main scale reading is 3.2 centimeters. Then, because the seventh line on the sliding scale, we call that the vernier scale, lines up with the main scale, we add 0.7 millimeters.
So we're essentially adding the main scale reading to a tiny bit extra that the vernier scale gives us.
Right.
And that tiny bit extra is what makes the measurement super precise.
Exactly. In this case, our final measurement would be 3.27 centimeters. It's all about combining the big picture reading with those fine-tuned details.
That's pretty cool. It's like using a magnifying glass to zoom in on those tiny increments that a normal ruler would miss. So that's the vernier caliper. What about the screw gauge? Is it similar?
It is, in that it's also designed for very precise measurements.
Okay.
But instead of sliding scales, it uses a threaded spindle that moves a little sleeve with a circular scale on it.
Okay, I'm picturing something like a tiny clamp with a dial on it.
You're getting the idea.
Okay.
And that dial or circular scale lets you measure things down to a fraction of a millimeter.
Wow, that's incredibly precise. But to be honest, those circular scales always felt a bit like a secret code to me. How do you actually read them?
It's like a puzzle. But once you get the hang of it, it's pretty satisfying. Let's say our screw gauge has 50 divisions on the circular scale. We're measuring a thin glass plate, and when we tighten the screw to hold the plate, the main scale shows 3 millimeters. And the 26th division on the circular scale lines up with the reference line.
All right, so how do we decipher those numbers?
Well, each division on that circular scale represents 0.02 millimeters because the screw moves 1 millimeter per full rotation.
Okay.
So we take that 26th division and multiply it by 0.02, which gives us 0.52 millimeters.
So we add that 0.52 millimeters to our main scale reading of 3 millimeters, and we get 3.52 millimeters for the thickness of the glass plate.
Almost.
Almost. Okay.
We need to account for something called zero error.
Oh. In more technical terms, what's zero error? Is that like when you mess up and get a 0 on a test?
Not quite. Zero error is what happens when the screw gauge doesn't read 0 when it's completely closed.
Okay.
Let's say when we close the gauge, the 44th division on the circular scale lines up. That means we have a zero error of plus 0.88 millimeters.
Okay, so we need to adjust our measurement to account for that. So
Yeah.
we take our initial reading of 3.52 millimeters and subtract the 0 error of 0.88 millimeters, which gives us a final measurement of 2.64 millimeters.
Exactly. It's a crucial step to ensure our measurement is as accurate as possible.
This is making me realize that taking precise measurements is a lot more involved than I ever thought. There are so many factors to consider, and we haven't even touched on percentage error yet.
You're right. We have a lot more ground to cover.
Okay.
But before we delve into that,
Yeah.
I think it's time for a quick break.
Okay.
When we come back, we'll explore how to quantify those errors and what it all means for interpreting data in the real world.
All right. Sounds good. I'm ready for a break.
Yeah.
So before we went to a break, we were talking about how taking precise measurements is more involved than we thought.
It is, yeah.
Yeah. So now I'm curious how we put those precise measurements to use.
Right.
Isn't there always some degree of uncertainty when we're dealing with real-world data?
You're absolutely right.
Yeah.
No measurement is perfect.
Right.
And understanding how those imperfections affect our results is a crucial part of the process.
Yeah.
And that's where the concept of percentage error comes in.
Okay. Percentage error. Yeah. I remember hearing about that back in school, but it always seemed a bit abstract.
Sure.
Can you break it down for us in a way that connects to everyday life?
Of course. Let's say you're trying to figure out the acceleration due to gravity using a simple pendulum.
Okay.
You know, that weight swinging back and forth on a string.
Right, right.
The formula for the time it takes for the pendulum to swing back and forth involves gravity.
Okay, so to figure out gravity, we need to know the length of the pendulum and how long it takes to swing back and forth.
Exactly.
I'm guessing we're not going to get those measurements perfectly, though.
Exactly. Let's say we measure the length of the pendulum as 10 centimeters. But our ruler is only accurate to within 0.1 centimeters.
Okay.
And we time the swing at 0.5 seconds.
Okay.
But our stopwatch is only accurate to 0.02 seconds.
Okay, so we have our measurements, but they each have a bit of wiggle room.
Right.
How do we figure out how much that wiggle room affects our final calculation for gravity?
That's where air propagation comes in.
Okay.
The uncertainties in our measurements for length and time
Uh-huh.
will ripple through the calculation and affect the uncertainty in our final answer for gravity.
So it's like a chain reaction.
Exactly.
One uncertainty leads to another,
Mm-hmm.
and percentage error is a way to put a number on how big that chain reaction is.
Exactly. It tells us how far off our experimental value might be from the true value, expressed as a percentage.
Okay, I'm following you. But how do we actually calculate that percentage?
There's a formula for that, of course. It takes into account the uncertainties in each measurement
Okay.
and how those uncertainties are compounded in the calculation.
All right.
For this pendulum example, the percentage error works out to be about 9%.
So that means our calculation for gravity could be off by as much as 9% due to those uncertainties in our measurements.
Precisely.
Wow.
And that's why it's crucial to not only be as precise as possible when taking measurements,
Right.
but also to understand and acknowledge the limitations of those measurements.
This is making me realize that even when we're using super precise instruments like those vernier calipers and screw gauges we talked about,
Right.
there's always going to be some level of uncertainty in our results.
That's an important insight. It's not about eliminating uncertainty entirely, but rather about understanding and quantifying it.
Right.
And that's what allows us to interpret data responsibly and draw meaningful conclusions.
This whole discussion of percentage error is making me think about how often we encounter numbers in our daily lives without really questioning their accuracy, whether it's statistics in the news, financial projections, or even those calorie counts on food labels. There's always some level of uncertainty involved.
You're hitting on a crucial point. Developing a critical eye for data and a healthy skepticism towards numbers is essential in today's world. Don't just accept numbers at face value. Dig a little deeper. Consider the sources and try to understand the potential for error.
I love that.
Yeah.
A healthy skepticism towards numbers.
Mm-hmm.
It's like a superpower that can help us make more informed decisions in all aspects of our lives. This has been such an eye-opening exploration of how measurements work and why they matter. But I'm curious, is there more?
There's always more to explore. But before we go further down this rabbit hole of measurement, I think it's time to wrap up our deep dive with some final thoughts and key takeaways.
So welcome back to our deep dive into measurements. And we've covered a lot of ground,
We have.
from those tiny but mighty significant figures to the domino effect of error propagation. And we even got, a little hands-on
Hands on you.
with some serious tools of the trade.
The tools.
The vernier calipers and screw gauges.
It's been quite a journey.
It has been, yeah. So what's the biggest takeaway?
The biggest takeaway for me is that measurements are so much more than just numbers.
Okay.
They're language.
A language.
A way of understanding and communicating about the world around us.
I like that.
Yeah.
Measurements as a language.
Yeah.
And like any language, it has its nuances and complexities. But once you kind of understand the grammar, so to speak, it opens up a whole new world of understanding.
Exactly. And one of the most important grammar rules in the language of measurements is understanding significant figures.
Right.
They tell us how much we can trust a measurement.
Right.
And they guide us when we're doing calculations with those measurements.
It's like knowing how many decimal places you can confidently use without making your data seem more precise than it really is.
Precisely. And speaking of precision, we can't forget about those tools that help us get those accurate measurements in the first place.
Right.
Those vernier calipers and screw gauges might seem a bit intimidating at first, but they're really quite ingenious in their design.
I have to admit, I used to be a little bit intimidated by those tools,
Yeah.
but now I'm kind of fascinated by them. It's amazing how humans have come up with these clever devices to measure things down to a fraction of a millimeter.
It's a testament to our curiosity and our desire to understand the world around us in ever greater detail. And it's not just about scientific research. These principles of measurement apply to so many aspects of our lives.
You're right. Whether we're baking a cake, building a bookshelf, or even just trying to figure out if that online deal is really a bargain, understanding how measurements work it can make a big difference.
It can, yeah.
Without being informed, being critical,
Right.
not just taking numbers at face value.
I couldn't have said it better myself.
Yeah.
Developing that healthy skepticism towards numbers,
Yes.
understanding where they come from and what their limitations are, is a crucial skill in today's data-driven world.
This has been such an insightful deep dive. I feel like I've gained a whole new appreciation for the power of measurement
Good.
and the tools we use to make them.
Well, I'm delighted to hear that. It's been a pleasure exploring these concepts with you.
And to our listeners, thank you for joining us on this journey into the world of measurements. Remember, every number tells a story,
It does.
and it's up to us to understand the language and interpret the message. So keep those minds curious and those measurements precise.